Hi guys. So here's the deal. The rest of this week is going to be a little bit weird with everybody coming in and out of classes. So I want to make sure you had the info you need and a video. So week 20, polynomial vocabulary and features. We've already talked about this. It was just a long time ago. And it's going to lead us into some other important parts of things with polynomials where we add, subtract, multiply, and divide. And dividing is trickier than it sounds. We're going to learn things about quotient rule and rational roots and all sorts of different things depending on all that stuff. So we're going to review some things this week, and then we'll crack into new stuff next week. And actually, we're going to save the determine features of polynomial graph for next week. When it comes to polynomial vocabulary and key features, this should be review, but you never know, right? So first, we're going to rewrite things in standard form. Remember what standard form is? So standard, first of all, we have to know what a polynomial is. A polynomial is only allowed to have positive whole number exponents. You can add and subtract. The number, the coefficients out in front can be anything they want. They can be fractions, they can be negative, positive, but these exponents can only be positive and integers, whole numbers, okay? And then to put them in standard form, remember, that just means to put them in, combine all your like terms, and then put them in order, okay? So let's do this example. And when I say in order, highest exponent first, and then exponents go down. We call that descending order. So with this example, rewrite the following polynomial in standard form. Well, which one of these terms? So here's a term, here's one, and here's one. Which one of those terms has the highest exponent on the letter? Well, sorry. X squared, so that goes first. That whole term, the coefficient, 1/8, and the variable, x squared, go first. And then the next one, let's see, is there an x, plain old x? Yep. So then we have 5x, and it's positive, so we're adding it. And then we have that plus 7. So when it comes to putting them in the right order, standard form, that's as simple as it gets. You rewrite them in the order from highest exponent and then down. Just be careful if there's any negatives. For example, if this had been negative 1/8, we would need to put a negative out front. Don't forget that. Okay. The next thing that I want us to talk about is the different polynomial vocabulary pieces, and there are lots of things to talk about with this guy. First of all, before we do anything else, let's go ahead and put it in standard form. So let's do that real quick. In standard form, which one is the highest exponent? It's this guy. So that guy is going to go first, 4x to the 4th. The next highest exponent, x squared. Next highest exponent, 6x. And then this little guy that has no variable whatsoever. And be careful, that's a -1, a -1 out front, so we got to put a -1 in here. Okay, so there it is in the right order. Now we're going to look at, first of all, what's the degree of this polynomial? Well, the degree comes from the highest exponent, whatever the highest exponent is. And in this case, the highest exponent is, right, whether you look at it up here in the original question or you look at it after writing it in the right order, that's up to you. But the highest exponent either way is 4. So if the highest exponent is 4, we call it 4th degree, and it has a cute little name, quartic. So this guy is a quartic function. And we've done stuff. We've done a lot of graphing things, and all dependent on the highest exponent. So these terms should be familiar. Leading term means once you've got them in the right order, it should be the one out front leading the way. But if you don't put them in order, you have to remember that it's the letter and the number that go with the highest exponent. So this little guy out here is our leading term, 4x to the 4th. Because that exponent is 4. That's our leading variable, and the leading term is the whole thing with the number out front, the coefficient out front, so 4x to the 4th. Now, the leading coefficient is just the number, not the whole thing with the letter and the exponent. So the leading coefficient here would just be 4. The easiest thing that you get to do on here is the number of terms. Once you've combined everything, we look back at this original question just because it has less stuff written on it. And we just count how many terms are there, how many different pieces are being added or subtracted together. So we got 1, 2, 3, 4. So there are 4 terms. Now, there's a lot of 4s on this particular example. That is not always how it goes, but that is how this particular one happened. Okay, now the next part of this that we're going to talk about is about the end behavior. And all that is a fancy way of saying is what happens on the ends of the graph, on the right side and on the left side. So what direction is the graph going on the right and left ends? So on the left side of the graph, we usually, the way that we say that is we say that the x approaches negative infinity. As x approaches negative infinity, that's the left side of this graph, right? As we follow this and we go to the left side, that's closer to negative infinity on x. And then the question is, what's the y doing? Is the y value or the arrow on your graph, is it going up or down on this side of the graph? Well, to me, is on the left side, it looks like it's going down. So as x approaches negative infinity, left, y approaches negative infinity, down. As x goes left, y goes down over here. Now let's look at the right side. On the right side, as you go to the right, x gets bigger and bigger and bigger, so we say that x approaches positive infinity over here. As x approaches positive infinity, is this y value going up or is it going down? Well, it looks like it's going down over here, right? So on the right side, it's going down, and this is the way we'd say that. We say as x approaches positive infinity, y approaches negative. So I'm going to put that down here in the answers, okay? So the answer to what is the end behavior of f of x? Well, I'm going to grab the right side. As x approaches infinity, y approaches negative infinity. Then I'm going to look at the left side. As x approaches negative infinity, y also approaches negative infinity, because on both sides of this graph is going down. So on both the right side and the left side, this graph is going down, and that's what this means. On the right side and the left side, this graph is going down, okay? So let's do one where the answers are all written out for us. We just have to find the right answer. So here's the graph, and what is the end behavior? Okay, so first of all, let's just look at the right side of the graph. Okay, so the right side of the graph, over here on the right. On the right, is this graph going up or down? Well, it's going down. The right side. As x approaches positive infinity, what's the y doing? It's going down. So we say y approaches negative infinity. So as we're looking through these options, we can already start ruling some out. As x approaches positive infinity, y approaches negative. Okay, so that's not it, because that says as x is positive, y is positive. This could be it. This says they're both positive, so that won't work. And this one says x is positive, y is negative. So there we go. Okay, so we've ruled out this one cannot be the right answer, and this one cannot be the right answer. Okay, so now let's look at the left side of this graph. On the left side of the graph, on the left side, is this graph going up or down? Remember the way we say left side, we say as x approaches negative infinity, what's the y value doing? Well, the y looks like it's going up to me. So y is approaching positive infinity. So as x is negative, y is positive. As x is negative, y is positive. That looks like that could be it. Because this says negative, negative. So that's not it. So there we go. Now let's talk about y-intercepts. Now this is easy peasy, right? Y-intercepts, remember, is just asking, does your graph, whatever it does, before and after, is not what we're asking about for this question. We're only asking about where does it cross the y-axis. And remember that on that y-intercept, your x will be 0. So we really only care about the y right now, okay? So since x is going to be 0, what we can do is we can just go ahead and plug in a 0 for x, right? We can just plug in 0 for x and simplify. So if we do this first one, if I plug in, I get 4 times 0. Okay, that's 0, right? Minus 0 to the 4th. Okay, that's still 0. Minus 7 times 0 cubed. Yep, that's still 0. Minus 8 times 0 squared. Okay, lots of zeros. Oh, and then a plus 9. So the answer to this guy, the y-intercept, is at y equals 9. Okay, let's do another example. Number 2, same idea. Plug in x equals 0 and see what happens. Okay, so 0 squared plus 2, that's 2. 0 squared plus 2, oh, that's 2 again. And we've got these parentheses, so they're telling us to multiply, not add this time. And then we've got 0 squared plus 3, and that's 3. All right, well, now we got to multiply all that together. 2 times 2 is 4, times 3 is 12. So that's our y-intercept. Last one, same idea. Third verse, same as the first. We're going to plug in 0 where we see an x and simplify. Well, that's negative 2 times 0 minus 1 is just negative 1. So we get positive 2. So we just did 3 quick examples of finding the y-intercept because they are quick. Okay. Now let's talk about the different features of polynomial graphs.